Alright, so section 2.1 is a big section, and it's going to be a longer video than I like, but you need to really make sure you know how to do this, not only for this lesson, but again for algebra, geometry, and algebra 2 down the road. And it's all about solving multiple step equations. So when we solve equations, our main goal is to get, right, the variable by itself, okay? Now, what I like to do is we're going to write down the steps for all of these and then come back to them. So what we have to do is simplify each side of the equation, which means we have to distribute on each side, and then, if necessary, combine like terms. Okay? Now, once we do that, then our goal is to move the variables to the left, and then move any constant to the right side of the equal sign. And this is by undoing undoing addition or subtraction. Now, once we're done with this, our third step is to basically undo any multiplication or division. Okay, so if you want to pause the video and write this down, that'd be great. Okay, so when we look at this through the next, for the 6 examples, catch on to the patterns on how I'm moving things, how I'm undoing operations, and all those good things. So, example 1, I look at this, and I look at the left side of the equal sign, and I see no distributing or combining like terms. I look at the right, nothing like that either. If I look here, I have all my variables to the left because I have no variables on the right side. So, do I have all my constants on the right side? No. So what I have to do is move this term over. Well, how do I get rid of it on this side? Well, since it's plus 14, I'm going to subtract it. Then I'm going to line it up under the 25. So I bring down the 3n. These should add up to 0 and eliminate. And then 25 minus 14 will give me 11. Now, I have my variables on the left, constants on the right. So the only thing I have to get rid of to get n by itself is the 3. Since that's 3 times n, I'm going to divide by 3. If I divide the left side by 3, I divide the right side. 3's cancel. I get n equals 11 thirds. Okay? Most of the time they will come out even, but not all the time. So keep that in mind. Next example. My goal is to get a by itself. So, what do I have to get rid of? I have to get rid of the 5 and this negative 4. Which one do I get rid of by using addition or subtraction? And that is the 5. Since this 5 is positive, to get rid of it, I'm going to subtract it. 5 minus 5 will give me 0. Subtract it over here. I end up, now, what do I have to bring down here? That's negative 4a equals negative 132. Okay, now I still have to get rid of the negative 4. Since that's negative 4 times a, right? To get rid of it, I'm going to divide by negative 4, divide by negative 4, and I would get a equals, a negative divided by a negative is a positive, and 132 divided by 4 would be 33. Alright, the next example, and feel free to try the problems and then come back and watch the video to see if you got an idea of what you're doing. So, here, I have to get rid of 2 things. I got to get rid of the 10 and the 6. Which one do I undo using addition or subtraction? That's the 10. Since 10 is positive, I'm going to subtract it. They add up to 0. Whatever I do to this side, I have to come to the other side, subtract 10. And I bring down the 6x equals negative 134 minus 10 is going to give me negative 144. Now, how do I get rid of 6? Well, 6 is linked to x by multiplication, so I'm going to go ahead and divide by 6. Those eliminate. Divide by 6. And x would be a negative divided by a positive is a negative. 144 divided by 6 is 24. Example 4. I have to get rid of 5 and 9, right? What do I get rid of by addition or subtraction? That's the 5. So, since 5 is negative, I have to add it. Those should add up to 0. If I add it to the left side, I add it to the right side. Bring down 9x equals 13 plus 5 is 18. And now it's easy to finish from here. Undo using division. Those cancel, and x is equal to 2. Alright? Example 5. So I go ahead and I look at this, and first thing I'm going to do is I'm going to go ahead and add the 4. Add the 4. Okay, these add up to 0. I'm going to bring down the m divided by 4 equals negative 3 plus 4 is 1. Now remember, if I have something linked by division, how do I undo it? I undo it using multiplication. And I always multiply both sides by the denominator. Multiply by 4, those cancel out. I bring down my m equals, multiply this by 4. 1 times 4 is 4. And I have m all by itself now. M is equal to 4. Okay, now this last one. There's two ways I could do this problem. One is I think most kids would like to rewrite this problem. I'm going to rewrite it as 9 minus x equals 14. Now, how do I get rid of this 9? Since it's positive, right? I'm going to subtract it. They add up to 0. Subtract. But you have to remember, I have to bring down this negative x equals 14 minus 9 is 5. Since that's negative x, I think of it as negative 1x. So I have to divide both sides by negative 1. And 5 divided by negative 1 is negative 5. Now there is a way to do it without rewriting the problem, but I do think it is to your best interest to go ahead and rewrite the problem. So there are 6 you-try problems that follow this, right? If you want, do me a favor, pause the video, do those 6 problems, and then you'll see I wrote the solutions here, right? Come back and check your answers, right? So I'll leave it here for you. Okay, so the next group of problems is solving multiple step equations or equations with variables on both sides, right? You can have all of this. So this is like the hardest of the hardest that you're going to have to do. Okay, so looking at this, the steps are no different than what we set up above. All right, your first step is going to be to simplify both sides by distributing if necessary, and then combining like terms. Then move variables to the left, constants to the right, and that's by undoing any addition or subtraction. And then last but not least, undo multiplication or division. Once you master how to do one or two of these, all of them are the same. So let's look at some examples. Look at this first example here. There's no distributing on the left side or right side, and there's no combining like terms on the left side or the right side. So now my goal is to move any variable on the right side over to the left side, then move any constant on the right side over, or on the left side over to the right side. So if I look to get rid of this x on the right side, since it's positive, I'm going to subtract it. Now you have to keep in mind there are like terms, and I have to align these like terms. So on the left side, what is the like term that would go with? And that's the 3x. So I subtract x here. Then, to get rid of this minus 4 on the left side, right, since it's negative, I'm going to add it. What's the like term on the right side I would line it up under? That is the 12, so I would add it there. So now I just add or subtract everything vertically. 3x minus 1x is going to give me 2x. The 4's eliminate, bring down my equal sign. X's eliminate, and 12 plus 4 is 16. Now I have all my variables to the left, constants to the right, so now I can just undo multiplication or division. Since 2 is linked to x by multiplication, I divide. 2 is eliminate, and x is equal to 16 divided by 2 is 8. And I am done. So the next one, right? Very similar. I have to move my variables to the left side, so I have to get rid of 4x here. How do I get rid of it? Since it's positive 4x, I'm going to subtract it. They should eliminate. The like term on the left side is the 8x, so I subtract 4x. Then I have to move my constants to the right side. How do I get rid of positive 5? I subtract it. Line it up under its like term, I subtract it. These eliminate, and now 8x minus 4x is 4x equals negative 11. That's negative 11 minus 5 is negative 16. Now all I have to do is undo multiplication or division. Divide by 4, divide by 4, x is equal to negative 4. Okay, now the next one. When I look at this one, as soon as I see parentheses, what do I have to do? I have to distribute. So I'm going to go ahead and distribute this negative 4. So negative 4 times 6m is negative 24m. Negative 4 times 3 is minus 12 equals m minus 37. So I've done all my distributing. I have no more parentheses. So now I can look. The left side, are there any like terms I can combine here? And the answer to that is no. I look at the right side. Are there any like terms? Answer is no. But now I have to move my variables to the left. So how do I bring the m over here? Since it's positive, I subtract it. I'm going to subtract it here. And then I have to bring my constants to the right. So that negative 12 has to go and come over here. To get rid of it, since it's negative, I add it. Add it over here. This will give me, when I combine like terms here, negative 25m. Those eliminate, equals negative 37 plus 12 is negative 25. And now all I have to do is undo multiplication here. Divide by negative 25, divide by negative 25, and m is equal to negative 25 divided by negative 25 is positive 1. So the next one, I look at my left side and I notice there's no distributing or combining like terms. I look at my right side and I do see that I'm going to have to, I don't have to distribute, but I do have to combine like terms. So I rewrite my left side as 11x minus 6 equals. And if I look, the 4x and then negative 3x can be combined. What is 4x minus 3x? It's going to give me 1x. Then I bring down the minus 16. Now I have no more distributing or combining like terms, so now I can work by moving variables to the left, constants to the right. How do I get rid of 1x? I subtract it, line it up under 11x. How do I get rid of negative 6? I add it to the right side. 11x minus 1x is 10x. 6 is eliminate equals 1x is eliminate. Negative 16 plus 6 is negative 10. And now all I have to do is divide by 10, and x is equal to negative 1. Okay, so next example. I look. On the left side, I do have like terms to combine. 4x, 3x, and negative 2x can all be combined. 4x plus 3x is 7x, right? And 7x minus 2x will give me 5x. Bring down my plus 6 equals. On the right side, I have to distribute. 3 times 3x is going to give me 9x. 3 times negative 2 is minus 6. Now my goal is, I have no more distributing or combining like terms, so variables to the left, constants to the right. So subtract 9x. 6 is positive, so I'm going to subtract it. Oh, it's just 6. And 5x minus 9x is negative 4x. 6 is eliminate equals 9x is eliminate, and negative 6 minus 6 is negative 12. Now, how do I get rid of negative 4? Undo multiplication by dividing, and x is equal to 3. Alright, the next one. First thing I have to do is simplify this side. Okay, and that is a combination of 1, I have to distribute. Negative 4 times negative 5r is 20r. Negative 4 times 2 is minus 8. Bring down the plus 7r equals 27 minus 8r. But if you look, 20r and 7r can be combined. That would give me 27r minus 8 equals 27 minus 8r. Now all I have to do is move the variables to the left, constants to the right, undo multiplication or division. So I'm going to add 8r here, add 8r here. I'm going to add 8 here, add 8 here. And if I look, 27r plus 8r is 35r equals 27 plus 8 is 35. Now divide by 35 and r is equal to 1. Okay, so this is very methodical. If you understand the process, look for distributing, looking for combining like terms, move variables to the left, move constants to the right. It's very straightforward and easy to do. Okay, now the last part of the lesson. There are some you-try problems here. If you want to try these problems and come back and check your answers, I'd highly recommend it. So here are the answers to the you-try problems. Alright, I'll scroll down. You can pause it to double check them. And now we will go on to the last part, special cases. Alright. Now, if I look, special cases mean there's two scenarios here. There's one is infinitely many solutions, right? Which is also known as all real numbers, right? Or there is no solution. These are the two scenarios we can get for special cases. Alright? Now, if I look at the first example here to solve, I'm going to go ahead and solve this like we just did. I'm going to go ahead and distribute, right? 2 times x is 2x, 2 times 3 is 6. Now, what you should notice right away is the left side is exactly the same as the right side. And when that happens, no matter what value of x you plug in the left side, the right side will always be the same. Now when I go to solve this, I'm going to subtract 2x, then I'm going to subtract 6, and what you notice here is you end up getting 2x minus 2x is 0, 6 minus 6 is 0, equals 2x minus 2x is 0, 6 minus 6 is 0. You get 0 equals 0. What this means is you have an infinite number of solutions. So if you're ever solving an equation and you get 0 equals 0, that's what that means. Okay? Now, 0 equals 0 means it's infinite number of solutions. Now, no solutions. If I go to solve this next example, 5 times x is 5x. 5 times negative 3 is minus 15 equals 5x plus 12. Now here, if I look, the 5x's are the same, but the 15 and 12 are not the same. So when I go to solve this, I'm going to subtract 5x here, subtract 5x here. add 15 here, add 15 here. Now notice what I get here. I get 0x equals 27. Is there any value that I can plug in for x to make this a true statement? 0 times anything is always 0. Does 0 equals 27? No. That's a false statement at the end. So if the x terms cancel out and you get a false statement at the end, such as 0 equals some number, that's going to be no solution. Alright, so right away here, I go ahead to solve this and I see 4x minus 3 equals 2 times 2x is 4x. 2 times negative 1 is minus 2. Right? Right away, if I see these x terms, when I subtract 4x, right, and then I add the 3, I end up with 0x equals 1. Is that a true or a false statement at the end? Is 0 equal to 1? That is a false statement, which means it is no solution. However, the next example, I go ahead and I distribute 6x minus 12 equals, combine like terms on the right side, 6x minus 12. Notice, right away I should see what the answer is going to be because the left side is exactly the same as the right side. But if I don't, subtract 6x, add the 12, and what happens is you get 0x equals 0 because everything cancels. 0 is equal to 0, which means it's an infinite number of solutions. Alright, so this completes the lesson. Go ahead, try the practice problems, check your answers, let me know if you have any questions, and then attempt the quiz.